Hello students, today we are starting the third module. The first portion of the third module is foundations and we are starting with the bearing capacity of soil. As we know that all civil engineering structures, whether they are buildings, dams, bridges, etc., are built on soil. A structure essentially consists of two parts, that is the superstructure, which is above the plinth level, and the substructure, which is below the plinth level. The substructure is otherwise known as the foundation, and this forms the base for any structure. The soil on which the foundation rests is called as the foundation soil. Functions of a foundation. A foundation is provided for the following purposes. That is, even distribution of load over a large area, for production of differential settlement, safety against sliding and overturning due to lateral loads, safety against undermining, firm and level surface for constructing superstructure. Bearing capacity of soil. As we all know, a foundation is required to transmit the load of the structure to the soil. Since the load from the structure is transmitted to the soil, it is important to study the strength and behavior of the soil. The foundation of the structure should be so designed that the soil below does not fail in shear, nor there is excessive settlement of the structure. The conventional method of foundation design is based on concept of bearing capacity. Now let's see the definition for the bearing capacity of soil. The supporting power of soil without any failure is called the bearing capacity of soil, or the maximum load per unit area which the soil or rock can carry without yielding or displacement is termed as the bearing capacity of soil. Or bearing capacity of soil is the maximum average contact pressure between the foundation and the soil, which should not produce shear failure in the soil. The bearing capacity of soil depends on the properties of soil like cohesion, angle of internal friction, density, shear strength, permeability, etc. It also depends on the allowable and differential settlement on soil, which depends on the bulk density, water content, etc. of the soil. The bearing capacity also depends on the position of water table. That is, whether the water table is very deep or it's shallow. It also depends on the physical features of the foundation like type, size, shape, and rigidity. Now let's see the terms related to bearing capacity. Ultimate bearing capacity, represented as QF, is the minimum gross pressure intensity at the base of the foundation that soil fails in shear. Normally, the term bearing capacity means ultimate bearing capacity. Net ultimate bearing capacity, represented as QNF, is the minimum net pressure intensity at which soil fails in shear. QF is equal to QNF plus gamma D, where gamma D is overburden pressure, or it is the unit weight of soil, and D is the depth of foundation. Net safe bearing capacity, represented as QNS, is obtained by dividing the net ultimate bearing capacity by a factor of safety. Factor of safety is usually taken as between 2 to 5. The various methods of determining bearing capacity are presumptive analysis, analytical methods, plate bearing test, penetration test, centrifuge test, and some modern testing methods. For the different types of soil, the safe bearing capacity expressed in kilonewton per meter square are soft rock 450 kilonewton per meter square, gravel 250 to 450 kilonewton per meter square, sand 150 to 250 kilonewton per meter square, clay 100 to 150 kilonewton per meter square. Now let's see the different types of foundations based on bearing capacity of soil. If the bearing capacity of soil at shallow depth is sufficient to safely take the load of a structure, a shallow foundation is provided. Isolated footing, combined footing, or strip footing are the option for shallow foundation. This type of foundation is mainly provided in soft rock or gravel. Deep foundations are provided when soil immediately below the structure does not have adequate bearing capacity. Pile, piers, or well are the option for deep foundation. For example, deep foundations are provided for bridges, dams, etc. Mat or raft foundations are useful for soil which is subjected to differential settlement or where there is wide variation in loading between adjacent columns. So that's all about the bearing capacity of soil. Thank you.